to go? OK, I'm told we are good to go. And people are still filtering in. That's all right. Let's get started. Hi, everyone. It's great to be back here. Thanks to the organizers for having me. Thanks for you for coming to this talk. My name is Martin Brown. I'm a developer advocate at JetBrains, working on pretty much all the topics that we're going to cover today. In this talk, we'll have a bit of a recap of what Kotlin Multiplatform is, how it works. Then we'll take a look at the stable announcement that we had last year, and as well as all of the developments that are going on since then and that are coming soon. I do have a bunch of slides, but I also have a bunch of live demos prepared here to the side. So we have that to look forward to as we go along, and just like have fingers crossed for me during all that. So Kotlin Multiplatform is a technology that allows you to write Kotlin code once and then compile it to multiple platforms. You can run it on the server side. You can run it on iOS, Android, desktop, or web. And if you're doing this on the client side, you can also optionally do UI sharing across the various platforms. For the sake of our examples here, let's imagine that we want to create a client application which will run on desktop, Android, and iOS platforms. In this scenario, we would have 4 different source sets when we're working with a Kotlin Multiplatform module. We would have our common sources, which can be compiled to all of our projects' platforms. And then we can have optionally platform-specific source sets where we can call the various platform APIs. But generally, of course, our goal here would be to write as much code as we can in common code so that we don't have to write it 2 or 3 different times. In common code, you can do anything that doesn't depend on specific APIs of a platform. So you can use basic language features. You can create classes, functions, and all that. You can also use things like collections and a bunch of things from the standard library, because these also generally do not depend on the specific platform that you're executing your code on. But what happens when you do need some platform-specific APIs? This is where the expect actual mechanism comes into play. You can create a declaration in common code of what you expect to exist, and then you can provide various actual implementations for each platform. Let's take a look at a quick example of this as well. For example, you can have in your common code a get platform function declared but not implemented. Because this is declared in common, you can use it anywhere in that shared code. And then you can provide platform-specific implementations. So for example, on the desktop target, we could use the system properties to grab the JVM version. On Android, we could use the build class to extract things like the Android version that we're running on. And we can actually do the same thing on iOS. We can use iOS APIs to grab the iOS version there. And this last one should be the surprising part. This is all thanks to Kotlin Native automatically mapping these APIs into Kotlin, whereas originally these are meant to be accessed from Objective-C or Swift. Of course, you don't want to do this every time you need to access something that requires platform APIs. So luckily, we have a great ecosystem and a growing number of multi-platform libraries that you can use. And if you are ever looking for a specific multi-platform library, the KMP Awesome repository, maintained by one of our colleagues, is a great way to start. As you can see, there are a lot of different categories of libraries you'll find here, whether it's for logging, for dependency injection, for testing, or just about anything else. For just one example of using a multi-platform library, I'll show you a quick snippet here from Ktor, which is a multi-platform networking library by JetBrains built for Kotlin. And here you can see that I've imported Ktor as a dependency. And because it's a multi-platform library, I can use it in common code. I can instantiate a client, and I can make an HTTP call without having to worry about how that will actually be implemented on each of the platforms that we're using. So once we've constructed this multi-platform module, we would then build our various applications on top of it. So as we previously planned, we can have a desktop, an Android, and an iOS application built on top. And each of these can contain their own logic as well as their own UI implementations written with the native language on each platform and with the native toolkits and libraries of each platform. And one of the great things about Kotlin Multiplatform is that you get to choose what you want to share. If you want, you can get started with a very small portion of shared code. You can share a single function, just one calculation, one algorithm, something like that to get started. This is also great if you're integrating this into an existing application that you already have. And of course, you can go the other way as well. You can try to move everything that's business logic into this shared Kotlin Multiplatform module so that you have just minimal applications built on top of your shared code. Okay, this talk's title was about Kotlin Multiplatform becoming stable. So let's take a look at the evolution of Kotlin Multiplatform over time real quick. The first step on the stabilization journey was the alpha in 2020. At this point, we were focused on Kotlin Multiplatform Mobile, so the code-sharing use case between Android and iOS applications. And around these times, we had technical advancements like being able to catch exceptions thrown from Objective-C on the Kotlin side, or the binary format of Kotlin native stabilizing so that you have backwards compatibility as you're upgrading your versions. Then beta was a big milestone in 2022. Here, the headlining feature was the new memory model landing. Previously, when you had concurrent access to objects, you would have to use special APIs to freeze those objects and things like that, which made it a bit difficult to write shared code that will be compiled to native, because native worked differently. But with the new memory model, we've done away with that, and you can just write your code the same way as you would for any other compilation target. Also around this time, we had tooling advancements, for example, KDoctor, which lets you check your environment setup quickly. And Google has also started introducing their first experimental multi-platform libraries within Jetpack. And that's how we got to the stable release around the end of last year, which we'll take a look at in a bit of detail in the upcoming slides. But this is the general production-ready and stable release of Kotlin Multiplatform. We'll take a look at that in detail in a bit. And of course, you'll notice that some time has passed since last November. So we'll also take a look at some advancements that have happened since then. So what does stability mean? Most of all, and first of all, it means compatibility guarantees. Kotlin Multiplatform is a complex technology. It consists of many parts across the language, the compiler, various pieces of the tooling. And Kotlin Multiplatform being stable means that you don't have to worry about your projects breaking as you're upgrading versions, and you can safely use it in production. You can learn a lot more about the details of stability of the various components by going to the link on the slide there. Something we've also improved significantly around the stable release in 1.9.20 was the configuration of your multi-platform projects. If you are targeting platforms such as iOS, where you have multiple different architectures that you're compiling to, then you would usually want to have a shared source set just for iOS architectures so that you can write iOS-specific code once, and then it will compile to each of those specific targets. For this, you would have to manually create source sets, as you can see on the slide here. You would have to set up dependencies between them, and so on. The good news is that by 1.9.20, we have done away with this. You no longer have to do that work manually. You can simply list your targets in the configuration of the Kotlin plugin, and we will create all those source sets and dependencies for you. The way that this works is by using something called the default hierarchy template. This is just a portion of it, but the full template lists all of the available targets of Kotlin Multiplatform. And what the plugin does is, as you add your platforms that you want to target, it will find them within this hierarchy, and it will create all of the default intermediate source sets, as well as all of the dependencies between them. So you don't need to do that configuration yourself. Once you do have source sets, you will still want to access them to add things like dependencies, for example. And we have also made that easier by adding typed completion as you're looking for a dependency. For example, if you're looking for common main, you can start typing that in your configuration file, and you'll get auto-completion and easily be able to select it. And the same goes for all of the other targets and source sets of the hierarchy, so Android main, iOS main, and so on. We've also made a lot of improvements around the stable release on the build and the runtime performance side, both of which, of course, are important priorities, especially with Kotlin native. We have added full support for configuration caching in Gradle, not just in the Kotlin Multiplatform Gradle plugin, but also in all of the Xcode-related build tasks, which didn't have this previously, as well as in the CocoaPods Gradle plugin. Then we now have an experimental incremental compilation for klib artifacts, which are native Kotlin libraries. Previously, there were build steps in the toolchain here where we needed to fully recompile all of your sources, and now we can do that more intelligently. We've also moved the memory management of the Kotlin native compiler into the compiler instead of having it implemented as part of the Gradle plugin, which gives us great opportunities to optimize things right within the compiler. And finally, to talk about runtime performance as well, we have a new custom memory allocator for Kotlin native, which can more efficiently manage memory for native targets by having different pages for different sizes of allocations, as well as different management strategies for these different page sizes. We also shipped new documentation so that it's easy to get started with Kotlin Multiplatform. The new development portal contains all of your entry points into learning about Kotlin Multiplatform, including sharing UI with it and all of the tooling around it as well. Something quite important with the mobile sharing use case is being able to call Kotlin code from Swift as you're integrating shared Kotlin code into an iOS application. And this is something where you have to be aware of how your Kotlin-defined APIs will look like from the Swift side and how the iOS application can consume them. To make this easier, we have created this Kotlin Swift Interopedia, which contains examples of many language features written in Kotlin and how they map into Swift. Also, this is based on a community project, so shout out to the original project here as well. Now, within this topic, the reason why some of the interop between Swift and Kotlin is difficult is because Kotlin, for Kotlin native consumption, is exported as Objective-C headers. And so whenever you're calling from Swift into Kotlin, you are going through this Objective-C bridge that exists in between. And there are some advanced language features, generics, and things like that, which are really difficult to do through this Objective-C bridge. And we are working on eliminating that, so exporting Kotlin directly to Swift, but I don't have any announcements on that today, but please stay tuned. All right, with that, we're going to head to some of our demos here. And the first thing I wanted to show you is kmp.jetbrains.com, which is the new entry point to create new projects with Kotlin Multiplatform. As you can see, this wizard allows you to set up basic things like project name and ID, and then you can select the platforms that you want to target with your application. So Android and iOS are selected by default, and you can also add desktop, web, and server side. And on the iOS part, you can choose whether or not you want to share UI using Kotlin as well. And then you can just download the zip file from here, and you have a project to work with. Not only do we have this project generator here, though, but we also have a template gallery where you have somewhat more meaningful starter applications that you can take a look at and build your own applications from there. As you can see, we have an app configured here with shared logic and shared UI. We have an app that has native UI on each platform, and we also have a library template if you're looking to get started with a multi-platform library. Next, I have to talk a bit about tooling. All of the demos I'm showing you today will be in JetBrains Fleet, which is one of our latest products. This is an IDE that's currently in public preview, and it's where we are putting our efforts for tooling in multi-platform. Let me tell you a few things about Fleet so that you have some context for why we're doing that. So when you first open Fleet, it opens as a lightweight, simple editor. You can browse your files, you can edit your source code. but it is just an editor at this point, and you have to turn on something called Smart Mode to take full advantage of its capabilities. When you do this, Fleet will take a look at your project, the languages you use, and load the appropriate language servers and code engines as a backend of sorts to provide code analysis, refactoring, run configurations, and more. In the case of Kotlin, for example, Fleet can load IntelliJ as a backend and provide all of the assistant and smarts from there. Because of this, in part, because of this capability of loading language support dynamically, Fleet also supports a lot of different languages. This is a sample of the languages it supports. And of course, the most interesting ones for us with Kotlin Multiplatform are going to be Kotlin and Swift. Not only does Fleet support these languages, but it can also understand the connections between code in Kotlin and Swift. So let's take a look at that. And from here, we're going to start hopping through demos, and this is our first one. So here's a project open in Fleet. We have a shared module, which is written with Kotlin Multiplatform, and then we have an iOS and an Android application built on top of it with native UI for each platform. Here I left this panel open, which shows up when you open a multi-platform project in Fleet. As you can see, this is essentially Kdoctor integrated into Fleet to make sure that your environment is set up correctly. You have things like the Android SDK, Xcode, and so on correctly configured. Let's quickly run this app and see it on both Android and iOS here. We have Android, and we should have iOS in a moment. This is a very simple sample app. We can essentially enter a circle's radius, and it will calculate the area for us. We should have iOS launching here. Let's try this again. There we go. So obviously the same thing on iOS. We can type in the radius. It gives us the area. But of course, the interesting part here is the multi-platform part. If we take a look at the iOS code here, which is implemented in Swift UI, we can see that whenever the button is clicked, it instantiates a calculator object. It calls a function on there and passes in the radius and gets back the area from there. And if I navigate into any of these declarations, we'll end up in the shared Kotlin code that it's using under the hood. So we can, of course, navigate from Swift to Kotlin. We can also do things like rename a declaration. Let's call this, I don't know, just circle area, for example. And if we now take a look at the usages, we can see that the renaming happened across both languages, both in Kotlin and Swift references. And we can also do debugging across languages. If I just rerun this on iOS with a debugger, which will take just a moment to instantiate. And of course, I've also changed the name of a method here. Just going to wait a moment here for the debugger to attach. There we go. We have the debugger. So now if I click in here, enter a number, and hit calculate, you'll see that we stop on a breakpoint. We are here in our iOS code. We can, of course, inspect variables on the Swift side. We have the calculator instance, which is shared code from Kotlin. We can step through the code. We can see the radius being parsed. And we can step into the circle area function, which means that we'll end up in Kotlin code. And here again, we can step through each of these lines and run this line by line. I'm going to skip this sum off, and we're just going to skip down to the bottom of the function here. We see that we can see all of the Kotlin variables in the debugger. We can see properties of the objects that we created, for example, this int range that's up here. And if we scroll down to the bottom of the logs here, we can, of course, also see the standard output from Kotlin in the iOS logs there. So we also have debugging like this. And if I keep stepping, we'll return from the function, end up back in Swift code again. And if I let go of the breakpoint here, then we get back to our application, which has displayed the value that we calculated from Kotlin, which I think is pretty cool. OK, let's keep going. So far, this is the client application that we were looking at. We had 3 different applications implemented on top of our shared code with their own UI implementations. But of course, we can also do something about that with Kotlin Multiplatform. And here is where Compose Multiplatform comes into play, which is a UI framework built by JetBrains for multiple platforms, built on top of Google's Jetpack Compose framework for Android. Currently, we support the following targets. We have iOS, Android, desktop, and web. On iOS, Compose Multiplatform is currently in alpha. It has been announced at last year's Kotlin Conf. On Android, running Compose Multiplatform is really just running Jetpack Compose, so that's of course stable. Compose Multiplatform is also stable on desktop, and it's currently experimental on web. And naturally, we are moving towards stabilizing these two platforms. When you use Compose Multiplatform, the experience is very, very, very similar to using Jetpack Compose. You are using the same APIs, the same foundational concepts. The only real difference is that that code now can live in your common main folder, and you can compile it and run it on multiple platforms and not just on Android. So that means that we can update our chart here, and instead of having platform-specific UI implementations, we can have shared UI written just once using Compose Multiplatform. But just like with Kotlin Multiplatform, this isn't an all-or-nothing decision of whether you want to share UI or not. You get to choose which parts of your UI you want to share and which parts you do not. So you can still interoperate with the native UI toolkits of each platforms. And if you want, you can have a single screen of your application that's written in Compose Multiplatform. And if you want, you can have its full UI shared using Compose and anything in between. At this point, I want to show you some of the latest developments we've had in Jetpack Compose, including releases from last week and yesterday. So these should make for some nice demos. Quick heads up here, these are generally still experimental, but we really do encourage you to try them out and give us your feedback so that we can stabilize them. So in Compose 1.6, which shipped a bit earlier this year, we have added support for using Compose Multiplatform resources, and we are continuing to make updates to that. Then I will talk about some Android X Jetpack libraries that have been ported to Multiplatform, which is a joint collaboration between Google and JetBrains to make this possible. So we're going to take a look at the lifecycle, the ViewModel, and the navigation libraries. Let's start with resources. So Compose resource handling for multi-platform looks very similar to Android resources. This time, you'll place your resources mostly in the common main source set under the Compose resources folder. Then you can share things like drawables, files, fonts, and values using this resource system at the moment. And you can also use a set of qualifiers so that you can have different resources per language, region, screen density, and light and dark mode. And of course, the best way to look at this is also a demo. So we'll hop over to this resources demo, and I'll launch it on iOS and on Android. And in the meantime, we can take a look at the code here. So of course, OK. In this sample project, we'll do a bit of font loading. We'll load the JetBrains Mono font as an example. That's what we're going to use for the title of our application, which will also come from string resource. We'll have a greeting on the screen, and then finally a logo displayed, which is a drawable resource. As you can see, the accessors for these resources is, again, very similar than on as it is on Android. So we have this res class that we generate based on the contents of the Compose resources directory. And in there, you can have typed access to things like strings, fonts, and so on. And we can also see the structure here in the project view on the left-hand side. So we have some drawables here, as well as a bunch of different string XMLs. Let's take a look at the application then. So as you can see, we have the greeting, we have the font loaded, and we have this drawable that's coming from resources as well. And if we start changing settings here, we'll see that the resources update dynamically. For example, if I go to dark mode with the Android application, we now have good evening instead of the previous string resource. And if we switch languages, which is so easy to do on each of these emulators. So let's do that on the iPhone side, and let's see if it's easier on Android. Yes, Android has maintained my settings stack. Very good. So we can switch both of these to French. And in this case, we have alternative resources and alternative drawables that we can load. So very similar behavior as on Android, and you can use all of these kinds of resources. All right. I want to highlight some things that are coming in newer versions of resources. As I mentioned, we already shipped this in 1.6, but we are adding improvements constantly. And in 1.6.10, we will have support for using these in multi-module projects, as well as shipping libraries that use resources, which was one of the important missing parts before. Then we have added some configuration options for the generated accessors, so you can control the package visibility and other options around it. We got a community contribution to Compose resources, which added support for plural strings, again, very similarly to Android. And we can also now have resource directories in multiple source sets, so not just under common main, but under more specific source sets of your project as well. All right, let's keep moving and look at lifecycle next. So the lifecycle library is, again, a port of the Android lifecycle library, but to multi-platform. So it will include lifecycle states like created, started, and resumed, transitions like on start, on resume, on pause that you already know, except we will now have mappings of these lifecycles for the multiple different platforms that Compose has. For example, on desktop, whenever your window loses and gains focus, those would trigger on-pause and on-resume events, or when it gets minimized or opened back up, that would trigger on-stop and on-start events. And of course, we have a demo to look at here as well, as soon as we can find it. We're looking for a lifecycle demo. OK, I'm going to run this on desktop. We're going to run it in browser using WASM, so on WebAssembly. And we'll run it on iOS. Of course, we also have it for Android, but it would be really, really boring to look at the Android lifecycle as a demo at this point. So let's just check out all the others. So here we have the desktop app and the web app side by side. I can hop between these. Of course, whichever one I have focused will have a resume state. And if we take a look at the logs here, for example, side by side with the desktop app, we can also see the state changes that it's going through. And I can also minimize this. It will go to created state. I can open it back up. It comes back to resumed, and so on. And if we take a look at the code that's powering it, we'll see that it's, again, the same lifecycle APIs as on Android. So we can grab a lifecycle from our local lifecycle owner with the composition local in Compose. We are collecting the lifecycle state of that, and that's what we're putting up on the screen. And I also have just a default lifecycle observer implemented here, which was printing all of the transitions into the logs for us. We haven't looked at iOS yet, but we'll see very similar things. Of course, I've increased the font size here 5 minutes before the talk. So now that's a bit too large for iOS, but we'll go with it. So currently it's resumed. And then I have a button here which navigates away from our Compose content on the Swift UI level. And as that happens, we can see that we have gone into a created state. And if I go back, of course, that previous screen gets resumed again. And I think we can shut down all of those at this point. All right, so that's life cycles. Next up, it's ViewModel. This is not going to be surprising. It's the same ViewModel you already know. It's in the Android X package. It's an abstract class. It has a method onCleared, which will get called whenever the ViewModel is being disposed, so you can shut down your various operations. And it has a ViewModel scope extension, so you can easily create new coroutines from your ViewModel. The interesting question with ViewModels when it comes to multi-platform is who will own these ViewModels, what's going to be the scope in which they exist, and when are they going to get cleared. So essentially, what will implement the ViewModel store owner interface, which provides the scope for all of our ViewModels. Well, on Android, if you're writing a single activity application all in Compose, this would generally be the component activity, which is essentially a global owner for all ViewModels within the application. And whenever your Compose code requests a ViewModel, that would be stored in the ViewModel store that's inside your component activity. Now, on other platforms, we can't quite do the same thing because the external components that host our Compose content do not have ViewModels store implementation. They don't have a notion of managing ViewModels. So in SwiftUI, for example, we don't have a global store like this. But for whatever hosts the Compose content within each application, so on the iOS side, that would be the Compose UI view controller. On the desktop side, that would be a Compose window, and so on. So those components that host your Compose content within the application, those do have an implementation of ViewModels store owner. So whenever your Compose code requests a ViewModel, that would be stored globally within that Compose frame of your application. And of course, you can also have more granular storage. We'll look at the navigation library in just a moment. But the navigation library, just like on Android, each of the navigation backstack entries it has can also store ViewModels themselves. So if you're within a destination in a navigation graph, you can request a ViewModel, and that will be scoped to the navigation backstack entry. And whenever you navigate away and it gets cleared from the stack, that's when it would dispose of all of its ViewModels as well. And of course, as we've seen, we haven't quite seen this part, but we've seen that the lifecycles are accessible through composition locals. In Compose, the same thing happens to look up the ViewModel stores. So you can just provide your own ViewModel store implementation, create a composition local provider for that, and control the lifecycle of your ViewModels completely manually if you wish. And very similarly, authors of navigation libraries may choose to use these same types, the AndroidX ViewModel type and so on, and provide their own scoping here. So navigation, I feel like a broken record here, but it's the same thing as with Android and Jetpack Compose, but you can now compile it for multiple platforms. Again, you have a nav host, you have various composable destinations, and you can navigate between them. Let's take a look at this code in the IDE and actually see it in action. So we're going to go to this project here, which is actually one of our template projects from the wizard that I've shown you earlier. And if we run this, again, we can do Android and we can do iOS here. If we run this, we'll see that we do have a Wi-Fi connection. That's very good. So as you can see, this is a browser for various images in a gallery. And I was a bit too happy about the Wi-Fi there. So if we navigate to any of these specific pieces of art, we'll get to a details page and we can navigate back. It's a basic sample for navigation. And here's the code again. We've seen this on the slide, but we can actually hop into these various destinations here. So for example, our list screen is a composable. It's fetching the ViewModel, again, using the same APIs. If we scroll up here, we can check the imports. It's, again, just the same ViewModel function. We're providing a factory for how to instantiate our ViewModel, and then we're collecting some state from it. And whenever clicks happen on the grid of images, we're using the nav controller that we passed in and navigating to the detail page, just like that. So that's navigation and ViewModel. OK, that brings me to the last topic I want to talk about today, which is going to be Emper. Emper is a new experimental build system that we're working on at JetBrains with the aim of simplifying build configuration and making it accessible to developers of all backgrounds. We are, of course, building Emper with Kotlin Multiplatform in mind from the beginning. And we really want to create a build system here which is toolable, which will be largely thanks to its declarative nature. And again, there's no better way of talking about this than just showing you some examples of how it works. So let's do that. We'll start here with a Hello World project for the JVM written in Emper. So we have a source folder here, which contains main.kt. I already have that open up here. That's just a Hello World function. And our configuration lives in this module manifest file with Emper, where we are declaring that this is a JVM application, so essentially a command line JVM app. And if we quickly compile and run that, that, of course, prints hello Emper in this case. Now, you may also see here that we have a bunch of Gradle-related files. And the reason for that is that we have initially implemented Emper as a Gradle plugin, which allowed us to really quickly start iterating and verifying the ideas with this product. So we are running on top of Gradle here as a Gradle plugin, which means we have the Gradle wrapper and all of those things included in our project. And that also comes with a couple benefits, because that means that you can introduce Emper into an existing Gradle-based project easily. And if there's anything that you cannot configure with Emper at the moment, you can always just create a build Gradle KTS file next to the Emper module manifest and use Gradle interop to configure more advanced things. So this project is really just a single module JVM application, I said. So we just have one module file here. And because we are using a declarative format here, we can actually see that if I just trigger completion, we get suggestions of all the different things that we could configure using Emper. For example, we can go ahead and start adding some dependencies. Let's say that I'm looking for coroutine score. If the Wi-Fi is with me, we'll get a completion for that. Maybe we're not going to get a completion for that. Do I have history for it? Yes, I do. There we go. So what we would have seen here, if Wi-Fi didn't give up on me, would have been that we get completion for artifacts from Maven, as well as their different versions. Ah, there it is. OK. So you can easily just start typing the name of a dependency in a configuration file, and then add it without having to go to readmes and so on. And then once we import that, we can, of course, use that as well. So I'll just modify my main file here a bit to use some code that actually has coroutines in it. It's the classic coroutine demo of launching 100,000 of them and eventually printing a bunch of dots with it. And of course, because we have imported coroutines, then that works now as well. But let's take a look at a more advanced project, which is configured with Emper. And this, again, is going to be the same template project from the wizard that we've seen earlier, where we have a shared module that contains basically all of the shared UI with Compose and so on. And then we have multiple applications, the Android and iOS app built on top of it. As you can see here, now our product type is going to be a library, and we can list the various platforms that we want to support with this library. Again, we have a schema here, so if I wanted to add a new platform, I have built-in completion for that. Then we have this settings block, which is generally where toolchain configuration goes with Emper. Here you can play with things like Compose and Kotlin settings. If you wanted to set up something like an SDK version for Android, you can also do that. And something really nice we have here in tooling is that you don't have to go block by block within this nested configuration, but we also have nested completion. So if you just start typing something like SDK, you'll immediately get results like Android min SDK, and you can easily start completing for that. Then we have a couple of examples of pulling in dependencies from various sources here. As you can see, we can use the Compose version catalog to easily pull in multi-platform dependencies for Compose. We also have the project's own version catalog, which is, again, a Gradle version catalog that we can access. So we have this libs accessor to pull dependencies from there. And we also have a bunch of different inspections and intention actions, which can detect if you are using hard-coded dependencies, offer to replace them with catalog versions. And we even catch things like using a dependency with a different version than what's in the catalog. And in that case, you get multiple different intentions that you can use. And as you can see, Fleet gives you a really nice preview of how exactly triggering that intention action would modify your various files in your project. And here, we'll just look at one more thing, which is that we have these qualifiers for dependencies. So this dependencies block is for common dependencies between all of your platforms, whereas these ones are where the platform-specific dependencies, like multiple Ktor engines, would go. And the same thing is true for the source layout here. So as you can see, we have the regular src folder where most of our source files are. And then we can have platform-specific source sets for things like actual implementations. And all of this is a very flat module structure in general. Let's look at just one more thing here. Let's take a look at what the iOS application looks like in this case. So again, it's an application product, so it's an iOS app. It depends on the shared module to grab all of that code, and it has Compose support enabled. So that's a 5-line build file for the iOS application. And we actually have just 4 source files here, which essentially set up our iOS application, set up our DI, and then the frame that the Compose view is hosted in. And as you can see, we have essentially 5 files for the entire iOS project here, and we can also have Swift and Kotlin files side by side in the sources. And of course, we could compile this as well, but we would see the exact same thing as before. Let's do that quickly for Android, but it's just going to be the same museum app. And I think I haven't run that in a while. If the emulator is with us. OK, my emulator is not happy. I cannot deploy to it. All right, well, it would have been the same museum app. OK, that's the wonder of demos. All right, so if you want to learn more about Emper, the best place to go is its GitHub page, where you can find detailed documentation, sample projects, and all kinds of resources to get started. We have an Emper channel on the Kotlin Lang Slack, where we very much welcome your feedback and thoughts about it, whether you like it, whether you don't like it. The reason why we made Emper public at this point is so that we can get your feedback and your use cases that you want to see supported. And if you have specific issues to report, you can also always do that on track. OK, if you have any questions about Kotlin Multiplatform, about any JetBrains products in general, really, you can, of course, find me around the conference. We'll also have the KMP office hours tomorrow with not just me, but a bunch of really knowledgeable people around Kotlin Multiplatform. And if you want to stay tuned to Kotlin news, a great way to do that is by attending KotlinConf, which I won't try to sell you on at this point, because we have luckily sold out a while ago. But what I want to highlight is that you can follow the entire conference, all of its tracks, on the Kotlin YouTube channel. And there are also KotlinConf global events, which you can go to. And I think there should be one even here locally. With that, here are some resources that you can find. You can follow me and find me on social media. You can find the slides and all of the links related to them on my website. And again, thank you very much for coming to this talk. And yeah, see you around the conference. Thank you. I think we have a few minutes for questions.